Greetings, fellow mathematicians. Welcome to a little corner of the internet called Marshable Math. Today's lesson is going to be on synthetic division, so get yourself a piece of paper and a pencil and a calculator. We're going to jump right in. Now, synthetic division is a way of doing polynomial long division provided that the conditions are right. If you remember from the polynomial long division video, we had this problem here, one expression divided by another one, and it took all of this method here to get it completed. Now this is actually the same method that you would use for regular long division with numbers, except instead of place values, we're actually using exponents of x, or the degrees of x. So this leading position here would be x cubed, then x squared, and then x to the first, and then x to the nothing. And we line those things up, line the columns up right so we can keep the place values of x in their proper spot. You'll notice here we didn't have an x squared in our original dividend, and so I had to put a 0x squared here in order to hold that place. Much in the same way that you would put a 0 in the hundreds place if I said divide 3045 by, something like that. You wouldn't write 345, you'd have to put 0 and then 45. So in the same sense, we need to have a placeholder here for that. So that's good work. It's a lot of work. We're proud of it. But boy, it's cluttered, right? It pains my brain to even look at that. So I've got x's all over the place. So I got an x over here and an x over there, and here's an x and there's an x and there's x's everywhere. So old MacDonald has a plan. The x's have to go. Synthetic division allows us to maybe clean this up quite a bit and only focus on the numbers, because if I keep the coefficients here, which is, remember, it's the sign and the number that's on the x's, if I keep the coefficients in the right position, the math sort of takes care of itself. I don't even need the numbers. So let's see what it might look like if I remove the x's. Take that one out and take that one out. Doesn't it start to look a lot cleaner? Makes you feel a little bit better about the math that you're doing. That looks a little bit better. Now remember, what were these things? This here was the x cubed column. This was the x squared column, right? See that there? This is the x to the first column, and then this last one was the x to the nothing column. If I can keep these numbers in their right place, I really don't have to write the x's, and that's the primary advantage of synthetic division. It also takes up a whole lot less space. Now, here are the conditions in which you're going to need to use this particular synthetic division method. You have to be dividing by a binomial here with x to the first power. It's got to be x to the first power plus or minus something. Basically, it follows this pattern here. It's got to be an x minus h. Maybe you've seen that before, like if you're doing parabolas or something like that with the vertex. It's going to have to be x to the first and then plus or minus something in here. So here's how this system will work. If all I need is the numbers, let me write down the coefficient matrix of the dividend. So I'm going to have a 3 here on the x cubed. I don't have any x squared, so I have to place a 0 there for the x squared. Now leave yourself a little bit of space. You don't want to push those too close together and make it think that it's 30, right? So 3x cubed, 0x squareds, 4 x's, and then 5 is the last term. And you see the little division bar here? I'm going to redraw that, but I'm going to do it upside down. Give myself another row here because I'm going to be putting numbers in. Let me draw that line right there. Okay. Now let's talk about the divisor. All I really need here is this number right there. But if it's x minus h, what is the h in this particular circumstance? Wouldn't it be -2, right? Isn't this going to be x minus a -2, like that? So the -2 is what I want. And maybe an easy way to think about it is just take whatever the number is right here and just do the negative of it. Okay? So I'm going to put a -2 right here, and I like to give them a little shelf to stand on. And what we're going to do is we're going to do a little arrangement now between these numbers. Follow along with me. The first thing we're going to do is we're going to take this first 3 and we're going to drop it straight down and write it down below. 3. Now what I'm going to do is I'm going to take the 3, the number that's down here, I'm going to multiply it by the -2. So 3 times -2 is -6. And I'm going to write that then in the next space over. So that would be -6. Now I add up this column. What's 0 minus 6? That's -6. And I just repeat the process all the way through. Take the number that's down here, multiply it by this one here, -6 times -2, +12. And then I add So that's going to be 16. Now I multiply. 16 times negative 2 is going to be negative 32. And then I add. That's going to be negative 27. Okay? And now I'm finished. I do a little wall right there. Because this is unique. These numbers don't go with that one. What number is that one? Do you recognize it from the previous problem? Look closely. Find it. It's the remainder, right? So this would be your remainder to the division problem. Look through now and see if you can find a 3 and a negative 6 and a 16 in a row like that. Press pause if you need to. But you got to find it. It's so good when you find it. Is it not the coefficients on your quotient? It is. So this right here, these are the coefficients on your quotient. You say, well, wait a minute, there's a structural problem here, because wasn't this the x cubed group, right? 3x cubed, and this was the x squares, and this was the x's, and this was the x to the nothings? Yes, that's true. But when we divide x cubed by something involving x, isn't the result going to be an x squared? Think about that. If you just take x cubed, ignore the numbers here, just think x cubed divided by x. Isn't the result an x squared? It is. And so what we've got right here is we have to realign the x values down one exponent. So if this is x cubed, the result down here is going to be x squared. It's called like the Prest equation because it's down one unit. Okay? So this is x squared, this becomes x, and this was x to the first, this is now x to the nothing. Put a plus there to keep it all straight. Look at that. That is my quotient. There's my remainder. Look at how nice and neat and tidy this all is. Okay? See if you can find these numbers here in that group. They're in there. I'll let you find them if you want to. But these are the ones that are actually like important. So those are the ones that we need. There's my timer. 2 minutes left. Okay, let me give you one and see how you do. I'll leave this one up so that you can use it as a model. And let's go. Let's do 6x cubed minus 19x plus 16x minus 4 divided by x minus 2. Go. Here's what I do. 6, oops, I'm sorry, that's squared. Rats. Sorry about that. 6x cubed minus 19x squared plus 16 minus 4, draw my bar. X minus 2, take the negative of that, plus 2. Okay, bring this down. 6 times 2, 12. Add. Negative 7 times 2. Negative 14. Add. Positive 2. 2 times 2 is positive 4. Add. Oh my goodness. 0. What does it mean when your remainder is 0? You've got a factor of the original. So this is now 6x squared minus 7x plus 2. That's your quotient. And so in the end, 6x squared minus 7x plus 2. There you go. Think about this. What if I actually substitute what if I substitute positive 2 into x, into this top piece, and just evaluate it? Would you give that a try and see what that works? Take negative 2 and just stick it in for x in the dividend. See what that gives you. Hope you enjoyed the lesson. I hope you learned a lot. Have a great day.